Hello guys. Let's start with where we left yesterday. So, जैसा कि right like we yesterday developed the queue manager and also did these interface method. Also completed these interface methods, which you can see here. Here's the queue manager, which manages the queue like registers and get the queue. And we did a heap implementation to sort the queues and a memory queue was built yesterday, which was in memory and had the operations of normal queue we defined earlier. Okay, for today we will first be looking at creating a interface for job handling and also implementing its methods, which we will do just here. Job handler interface and handler registry. So let me start with that. First, let's create a handler. Let me delete the git file. So basically, the job handler's work here is just like the queue manager we built yesterday. It's just to register the queue and to get the register the job and to get the job we want. So it will be simple. Let me define its interface first, and then we can start uh, with the implementation. Okay. So I'll start with creating a type handler, which is an interface. It will have two methods. For here we can just interface. What should I define here? Okay, what should I define here? That's the question. Question. Since it's an interface and we are going to use it, let me just think about this. We can the interface should be beautiful, like that's the main goal. Okay, let's create the interface. I think handler. It should have two methods: register the job. Okay, it should register the job and it should get the job. But there can be multiple handlers. We might need multiple handlers like job handler or something like that. Should I define here? That's the question. What if I define something like handler, which will take a context and a job, which is type of job and it's a pointer to job. And what will it give? It will give just an error. Okay, I think this much will work. Okay, now I'll define a struct for the registry. Since it's a job registry, struct for a registry. It's a job registry. The main two functions it will have is register and get. So where will we store the data? The thing I'm thinking of is using a map with the key of string and a type of handler. Okay, I think this much is Good. Yeah, this will work. Alright. Now let me create two methods which will be register and get the job. Okay, let me create the methods. Func, which is on registry type. It will work on registry type. Let's name it something like reg. Okay, register. The function name should be register. It will take two things: a job type, which is a string. Now you might be wondering where the job type came from. We have defined it in job start. If I can show you, yeah, here we have defined a job type. So we are just going to handle which jobs are handled by which worker. So the registry is needed. You'll get the hang of it once we go further. So it will take a job type and type handler. It will take an interface. Okay, after type, it will take an interface. Now let me define that function. Before that, I need to create a new job registry. It will take just a it won't take anything. Let's create a new registry function like we created yesterday with a new queue function. So it will be outputting as a registry pointer. It's an easy function which will return will make a map of type string with key string and value handler. Okay, what's the error? Cannot use make value of type string value in return statement. Why can't it use? Oh, I need something like typecasting. So I can just copy, cut it, and I will return the registry name with the handler equals to this. I think a handler will be a better choice here. Okay, what a registry can have. Okay, let it be handler or handlers. No interrupting. Okay, now the thing is we will define the functions for registering a registry. It might sound weird, but it's easy as it can be. Also, one thing more, we will need a mutex in the registry just to lock it so that at the time only one worker can interact with the registry. So there's no race condition. Since this will be a right task, let's go with lock. I'm using reg.mu.lock and we will defer reg.mu.unlock. The simple task we'll do here is we'll set the handler with a type with the given job type equals to head. Done. And now we also write a function to get a particular registry. Get a particular job from a registry. Job handler from a registry to be particular. Okay, it will be our star registry. Get it will No, it will take job type string, and it will return as a handler. Oh, sorry, and a type handler and a bool. The bool will dictate us whether it's okay or not. Like, have you seen functions in Go, which tells us if that's the right operation or not? Yeah, you will get the hang of it. Let's try and the combo. That's better. Now we will just argue. We will mutex dot rlock because it will be a read operation. And for mutex dot log veg dot mutex dot rlock. Nice and easy. Now we will just check whether the thing we are searching for exists or not, which we can check from here. Reg.h reg.handler of current job type. Nice, and we will return h common. Okay, sorry, I think the registry is done. The handler interface is done, this is done, this is done, everything is done. This will be used later once we start the implementation of the handler. For now, stick with it. It's just a registry, registry that registers the job and gets the job based on the job type. Okay. Next thing we will do is work on the worker. This one is main thing. Okay, so we need to define a worker pool. Multiple workers will interact with the queue at once, queue or jobs at once. So we need a pool which can start n go routines, and also it can cancel all the go routines at once. Okay, so the thing we'll do first is create a pool struct. Let me just here's the folder worker. Here's the folder. The name should be pool.go. Yeah, that's fine. Let me just confirm. Is the worker, yeah, pool.go, where we'll define the goroutine pool and the structure. Audit type pool struct. Okay, so we need to define the pool struct. Since it's a pool, it needs to a pool of goroutines will interact with the queue at once, with a single queue at once. So we'll need a queue, which is a type of queue dot queue. Yeah. Okay. Next, it will need to know the store of the job, like where to save, get, update status and all. So we'll need a store of type job dot store. Let me dot store. Okay. Next thing we will need is a registry we just created, and to that registry we will need a pointer. Registry history dot handle history dot. I'm writing something wrong, I think. This is not the right page to get. Handler, yes, it's handler dot registry. That's what we need. More things we need are there are multiple things we need. For them, we need to define some interfaces and structs. Let me just think. Should I define them now? Or should I define them later? For now, let me define the structs. I'll define the implementation later. So I'll define a struct for retry key, which will be retry dot. Okay, then we type the retry engine type is a struct. It will have 3 things in it: a base delay, after how much delay we need to retry, which is just time dot duration, a max delay, so that we can define maximum delay. The retry engine should target the retrial after once we reach the max delay. N request will happen after that will happen after that particular time. Let's say it's 10 minutes. So if a request fails multiple times and it has reached the max delay time, then we will retry the request until it's dead after 10 minutes each. I think you will understand. And a counter for max retries. It will dictate how much time can we retry. Okay, this much is enough. Okay, we will need a retry engine. Okay, we will need a retry engine. What should I name it? I think naming it retries. Okay. Pointer to retry engine. Okay. We need to define methods for this. Not divide. Okay. Methods not defined, to be particular. So, one thing we need further is a dead letter queue. A dead letter queue will be a queue which will store which jobs are dead. Or we can see, let's construct. Should I construct a dead letter queue? Dead letter queue for now. Let me just write it here as DLQ. We will get to these parts later. DLQ, it will need a DLQ, which is a dead letter queue. It will need a matrix system, which will define it as matrix system, which we will define later. Like we will define it once we start taking metrics. We'll use Prometheus for this. The next thing we can define right now is workers. The number of workers in the current pool. Okay. Then we will define a wait group. Wait group will be responsible for waiting on the processes to finish. Sync, not wait group. I think this one will work. Nice. Next, we will need a context. let's name it CTX so that errors like yesterday don't come. Context context, and lastly we will need a cancel function for the context so that we can cancel all the processes in the queue. Cancel, which will be of type context dot cancel function. I think this much is good with the pool structure. Okay. Now we will need two methods on the pool, which will be start and stop the pool. Okay, let me think through it. What will the start method do? Let's define a method which will work on pool of type to start. We'll take any argument. I don't think it need any argument. It's self-sustained. We'll do something like start. So what will start do? It will spawn n goroutines. Okay, it will spawn n goroutines, and also it will add into the wait group while adding the goroutines. Yeah. Let me define that. That's what I like about Go. The thing is persistence. The thing is concurrency is pretty easy. I wrote once concurrent C server. It was hell, to be honest, but it was fun. Hold on, the workers I plus plus. Now Go will complain. We can modernize it. We'll think about that later. Let's just add into the wait group. Add one, and we will spawn a goroutine. Go. Now, what will the goroutine do? That's the main question. What will the goroutine do? The goroutine's work should be to run a worker. And what should the worker do? Let's think about it. The worker should take the job, most recent job, which we will get from dequeuing the queue. Okay, and then it will process that job. Okay, it should process that job. What should be processing? Let's just define some functions before going further. We'll write about the start and stop functions later. Let me just define the stop function too. Before that, we will need pool stop. These are empty methods for now. Let me just think about firstly what the goroutine should do. It should run a worker. So let's define a function which will run a worker. Func which will work on a pool. Pool pointer. To the pool pointer, and it will run a worker. It is internal method, so I don't think we need to export it, so I will write it in short. So this is the quirk of Go. Like if we define the name of a method with the capital letter, it can be imported by other packages. But if we define it by lowercase, then it can't be imported. It will be internal function. It will take ID of type int. So what's the ID, you may ask? ID is the job ID which we created using Snowflake. If you remember, we created a Snowflake generator Everything will click once we merge all these things together. For now, stick with me. I think this one will go like this. And next, our function should run worker. So let me define what run worker do. Run worker will defer to will defer to hold dot what wait group dot done. Once run worker is finished its work, we can say that the process has been done, and we will use a for select pattern here. Okay, for select. It's pretty common pattern in Go. For select. And enjoy it. Case. The first case will be, what if the context has been done? What context has been done? Then what we will do? Then we will just return. Okay. Next case should be. Should I define it? Let's use default. Why define a case? Default will work. Nonetheless, it will check the job from the DQ of the pool. Pool.q.dq. As you remember, DQ will give us a job and an error if anything occurs. So let me pass the context. The context will be pool.context. Nice. Context is a pretty good package. If you don't know much about context, I'll say read through it. It's pretty good. It makes concurrency pretty easy. And if error occurs, what we will do is what should we do? We should continue. If error occurs, it means the job is not ready, and we should continue. If job is not ready, we should wait for the job to be ready. So let's do something like sleep for like time.sleep. Give me a second, guys. I have to attend a call. थोड़ी देर में टाइम स्ट्रीमिंग करूंगी. Oh, sorry for the interruption. I had to attend a call. So I was saying we should wait for the job to get ready. Let's wait for around 100 milliseconds. That's good, I think. 100 milliseconds. Time dot millisecond. Microsecond will be so little. Should I expect a millisecond? Let me format. If there's an error, it means the job is not ready. You can see here, we can go to one of the implementation, which is like this, DQ. It throws an error if queue is empty or if there is no job. So we can just wait for a job to be added or to be ready. Next, what we will do is, if this is done, we will process the job. Now process, we need to add a function, process the job. Let's create a function for processing this job. Func, which will have pool, star pool, process job. It's again an internal method. It will take a job J O. Let's write J. I don't want conflict like yesterday. Job. Okay. So what it will do first? It will change the status of the job. If you remember, we have an interface defined here. Like interface is here. It will update the status. We will define the methods later. But for now, update status is an interface which will update the status, and if something goes wrong, it will throw error. Okay, let's write. We will mark the job as running. Firstly, we will mark the job as running. You can see from here, let me show you. We have pending, running, done, failed, and dead. Initially, the job will be in pending state. Once it's started, it's get into running state. When it's finished, it's done. It's in done stage. If it fails, it's in failed state. Or if the job has retried multiple times and there is no response, it will be in dead state. We will handle that later. For now, let's mark the job as running. Job is ready. Okay, so what we'll do is use the method we had store pool pool dot store dot update status. It will take context pool dot context and a status. We want id, that will be j dot id, and a string status that will be running. Okay, let me see how it's defined. Where's the status? Yeah, it will be status running. Okay, job dot status running. Cannot use constant running of type string or string type as string value in argument to pool or stored. Why can't it use sorry, j dot status running? Nah, that should not be. Job dot status running, this should work. Like, I think it's a cost. We need to update the store to use cost id, cost string. Is something like this possible in Go? Cost status string status cost. I don't know. I could search. Nah, this is not it. Cannot use job.status running. Constant running of string type job.status as string value in argument. Incompatible assign. Isn't it just a string and we are expecting a string? Then what's the problem? The problem is cost. We can see the problem is cost. Okay. Cost is our problem. What we can do about it? Let me search Google. I'm trying to pass cost into function that accepts string input and string function. And type string constants can be passed directly to function accepting string because the Go specification. However, if you define custom type based on string type string, the compiler status. I think we have defined a. Let me remember. Yeah, we have defined a status, but it shouldn't be like this. Why is there error? Let's ask our AI. Explain. What's the issue there? You are reading a name type versus base type mismatch in Go. Job.status running as type job.status a custom type, but update status appears to expect string. Casted call site. Change update status to accept job.status for stronger types. Update status. Yeah, we should define the store like this. It should take status of type job dot status. What's job dot status? Why is there an issue? Not type. What's the issue here? Date status ID string job dot status. Job is here. We have strong. It's not a type. I remember it's a type. Okay. We can use status directly. I think. Yeah. We have defined the type here. I remember. Yeah. We have defined. Why is there? Okay. Now it should work. Yeah, it's working. So what it returns is an error. Do we need to worry about the error? What can be the error? If the error persists, what should we do? If an error occurs, let's see. Yeah, equals to throw error. If error occurs, what should we do? What can we do? Let's English. If an error occurs while if error occurs while updating the status, that means what that means is it doesn't want to update the status anymore. Why? How can that happen? Is it being controlled by any other? Should I handle the error? Should I just return the error? If I return the error, what will happen? We will get here and then the process job and it will process the job and return the error to the user. Do I need to show the user about the error? I don't think so. Let me ask my AI agent, what should I do there? How should I handle the error? Because handling, I'm thinking if I handle the error like say I throw the error, then the user who is using our queue will know there's an error in updating status in the queue. Should I expose that to the user? Should I just return the error and expose to the queue user and there was updating queue status, updating job status. I don't think so. This is optimal approach to just return the error. Let's see what it comes with. No, don't expose the raw error for this line. Treat it as internal worker, not a user facing queue. Return the error from process to job to the worker loop. Yeah, it will go. So the worker can decide to retry queue behavior. So retry queue, requeue behavior. add the error into the main error, for example, failed to transition job. Go to external user should see stable errors. Dashboard or now the clean pattern purpose and grab errors. For now, let's just let's return an error like error not new error updating job status. We will handle this error and what we will do is, if an error occurs, we will retry the job after some time. Okay, that will be handled by run worker or the handler mechanism. Alright, that's the topic for later. Let's write more functions. Okay, next we will need is, after updating the status, what we will need is, if the job panics, then what we will do is, we'll make the job status failed. Yeah, we need that. So what we will do is, after processing the job, we will run a function. So running this function that will just like, if r, let's say r equals to recover, if r equals recover, r not equals nil, it means there was a panic, and if there is panic, we'll just simply do something like this: update status. We'll format the document, format variable. I think this looks good, and will update the status to status failed if the job panics. Now here we don't care about error, but we should care about error. But the job has panicked. This is thing to be job has panicked and update status has not worked. Let this be like this for some times. We'll update everything later. For now, let's focus on speed rather than perfection. Okay, second thing we'll do is, first thing we have done is mark job as ready. Second thing we will do is, what is this? Oh, I did call function. Yeah. Second thing we'll do is get the handler for the job. Okay, we just wrote a registry. We'll get the job handler from here. As you remember, it gives some h in OK, which will be handler into OK equals to okay job registry dot get and there is registry in the pool.registry dot get what we just get with j dot type. Yeah, this will work fine. If we get the handler, then it's okay. If not okay, we'll update the status as failed. Okay. If not okay, we'll update the status as failed, and we will return. Yeah, this is okay. Let me get the from. Yeah. Since it's a point where the queue failed, we should return from here. You might have wondered why I didn't write return, because it used defer will run after process job is completed, and here we didn't need to return, so that's why I returned here. Return, that's alright. Next we will need is to execute the handler. Okay. 3 execute the handler we got. So how we will execute the handler is by using the handle. We define the handle here. We have to write its definition later, but for now you can just use it. Okay, and that handle will need context, pool context. We should pass pool.context and a job. What it returns is an error. Let's check the error. Error equals this. If error occurs, we should update the status again to status failed. Same thing again. No. I don't have it here. Let's copy this. I should do if error will do error if pool show, and this is done. If update status fails, we will error updating the stop and return. Yeah, this is what we need. Lastly, if everything works fine, we will mark the job as done. For now, this much is enough, I think. What we will do is mark the job as done. It will run pool store update status. That will be pool of context j.id and job status done. Yeah, I think everything should work as expected. A bit panics. What I'm thinking is, instead of using error here, we can do something like this. We can comment this out. This will make the function panic. So if the function panics, it will go into the recovery phase, and then everything will work. Right. So there is no need for this. Also, again the function will panic. This recover work in a loop. and let it remain like this. For here, we can just use not okay. We can just use this status and we will just return. Before return, if the job has panicked, it will go to the defer. Okay. Next thing we'll do is here. We'll remove this one and we will use this one. These error don't make sense. If error occurs here, we will need to handle the error. If error occurs, we will update the status to failed and we will return undefined error. Oh, I forgot all this stuff. Yeah. I think this function looks good. If panic occurs, it will go to recover stage. If it recovers, update the status. If the anything wrong happens, it will just throw an error which is error updating job status. I think everything should work fine from here. Let's use go run worker. Run worker, or we can simply run worker if I'm not found. No, we can't. Run worker with and ID. So the worker ID will be I0 to the number of workers we have in this pool. Right. The next thing we'll do here is process the job. Pool of process job, that will be job we just got. Yeah, no name problems. Next thing we'll do is define the function for stopping the jobs goroutines, which will be pool dot cancel will be called, all the context will be cancelled and all the dunks will be done, and it will wait for jobs to finish. wg.wait. I have added the job, I have waited for the job, I have completed the job, and I think everything is looking good. Where's the issue? It's really important this. I think pool looks good for now. Let me check what node do I need to do today. I think this much is enough. I have created a worker pool today. As you can see, a pool. We will write these things later when we implement their interfaces and all that. And it has start function and stop function which are exported. Unused parameter ID. Whoa. We have done an issue. What are you doing right now? Here I can see we have passed ID, but we are not using ID. We are not using ID. Should we use the ID? ID, pool run worker with ID this. Do I need worker ID? I don't need this. For now, let's just do this. Can we use this like that? This is not visible. Let's just not pass the ID. It will just run the worker from. Okay. I think this is okay for now. The new call not used. If we don't have returns in now, so we'll need ID. it was not an issue there. ID int. Now if we pass ID from here, no, it's still an issue. Package error implements function to manipulate error code. Rule of error logging call not used. Return natural return. I can't return error. If it doesn't return an error, let's just omit this one. If it panics, it will be handled by this. I think I have to do some work here, like yeah. ID is still not being used. Unused parameter ID. Should I use ID? How can I use ID here? Let's just keep it as it is. We'll do perfections later. So today what we did is implement the post struct, implement this method that is start and stop. Start will run a worker and then process the job. Stop will stop all the process goroutines. And also we created a handler, that handler registry. I think that is enough for today. Already today's Sunday, so I think that's enough. Okay, bye guys. Thank you.